Welcome. This video covers reshaping data with the tidyr package. We haven't talked too much about the idea of different formats of data that you would have. We've mostly been assuming that we're going to have a 2D rectangular data set where each one of our columns represents a variable and each one of our rows represents an observation on that variable. And really what that means is that we've been assuming that we've been working with long format data. So with long format data, this is one observation on unit A. This is another observation on unit A. So long format data has its data set in this format. Each row is representing a single observation on a particular person or patient. Now, that is great because this is how statistical software generally wants to have its data. If you're going to do modeling, this is usually the kind of thing that you want to have your data in, the kind of format. If you're going to do plotting, this is usually the format you want. But it's not the most compact way to actually view data. So if you deal with Excel spreadsheets a lot, people usually put data in Excel spreadsheets, well not usually, but quite often put Excel spreadsheets in wide format because it's easier to look and view the data. Okay? So easier to view your data, but not preferred by software that's going to do analyses and plots. And what you can see here is that each row is no longer corresponding to a single observation on your patient or on your person or whatever it is. Instead here we have patient A and we have 3 observations on that single patient. And so, on one patient. And so that's not ideal for your software. And so sometimes you're going to want to take wide format data that you have and transform it to long format. And sometimes you're going to have long format data and you want to summarize it or show it to your reader. And so you don't want to put it in this format, so you want to switch it to wide format. So we need to have functions that are going to allow us to do this pretty common data manipulation. So this is where the tidyr package comes in. It's again part of the tidyverse and it comes preloaded when you read in the tidyverse. It's one of those 8 packages that gets read in. And so these 2 important actions I just talked about can be done using these 2 functions here. Pivot longer takes a wide data set and makes it longer. And pivot wider takes a wider data set, takes a longer data set and makes it wider. So these 2 are going to be able to undo each other in some sense. Let's look at some data that's already in wide format. We haven't really read in any data that looks like this yet, but there's this file that's available on the web called citytemps.txt. And this is a space delimited file, so we're going to read it in using the read_table function from the readr package. We're going to save that as an R object called temps data, and this is what it looks like. We can see here that this is wide format because we have multiple observations within a particular row, right? For Atlanta, we have 7 observations for the temperatures for the days of the week. And so again, if you're going to try to plot this data or do some sort of modeling on it, generally speaking, R and other software would not want this in wide format. It would want it in long format where you have 1 observation per row. All right, here we can use the pivot longer function to say, hey, I got a wide data set, I want to make it longer. And the arguments to pivot longer that you need to know about are these 3, generally speaking. So there's calls. This is the argument that specifies which columns you want to make longer. So in this case, we would want to specify from the 2nd to the 8th column. We want to make these ones longer. And then you need to say, well, hey, where do I want to get my names? What do I want to make the new variable names? So these are the new names for the columns that we're going to create. And in this case, we're going to create a new variable corresponding to this right here. So what are we going to call the names of our new variable that corresponds to those old variable names? So where are we going to take the names that we had up here and send them to? Well, we're going to send them to a new variable called day. And then we need the values_to argument. And this says, take these values. What's the new variable that's going to correspond to the values? Values_to, and we're going to create a new variable called temp. So that's it for pivot longer, the 3 things that you really need: calls, names_to, and values_to. So here's an example of calling the pivot longer function. We're going to say the columns 2 through 8 is what we want. The names_to, we're going to take the very old variable names from the wide data and put them in a new variable called day. We're going to take the old values from the wide data and put them in a variable called temp. And so now we can see that we have a long format data set. We can see that because we have one observation for each unit per row, right? So Atlanta now has only one observation here. Atlanta has another observation here. So we have long format data, which is perfect for software. Okay, and so what's really great about using the pivot longer function is that you can utilize all of those same functions that we used whenever we were selecting columns. So select had all those functions like ends with, starts with, contains. You can use any of those kinds of functions here to specify which columns you want to pivot longer. And so one of the other things we can do is just that colon operator. So sun colon sat, that will say all columns between Sunday and Saturday. And so we go back to our original wide data. Here's Sunday, here's Saturday. That notation is another way of saying columns 2 through 8. So we get the exact same data set coming out. All right, what if I have long data and I want to make it wider? Well, that's what pivot wider is for. And so pivot wider is just basically a way to undo the operation we just did, right? We just created this long format data set. And what we can do is, if we wanted to go back, we can use pivot longer or pivot wider to switch back. And rather than names to and froms to, rather than names to and values to, we're going to have names from and values from in this case. And so names from is just specifying which variable is going to correspond to the new variable names. In this case, we have this day variable that's going to correspond to our new variable names. And then values from says, well, which one of my columns or which column or columns do I want to actually get the new values from for these variables? And I'm going to say, well, I want to grab it from the temp variable that we just made. So this will completely undo the process that we just did. All right, another really useful thing that the tidyr package allows us to do is either separate or unite different actual column values themselves. So for instance, we have this date variable in this case. And so you might say, well, I want to split this up to have the day, the month, and the year be, the month, the day, and the year be different variables. So that would be separating a single column into multiple columns. So if I want to separate, I can separate this thing into these three variables here. On the other hand, if I have three variables that I want to combine together, I can unite them by going the other way. So again, we have functions that are complementary of each other. So let's see how to use those. We're going to read in a data set called Chicago data. Called chicago.csv, again available on the web. We'll use read_csv, and we'll have a new object called Chicago data. Now this has a variable just like the one we were just looking at. So it has a date variable, and maybe like we said before, I want to split this up into month, day, and year. So three new variables. Well, then I want to separate that variable. So I want to run the separate function and create those variables. So what does separate take in? Well, separate's going to take in which column you want to split up. So I'm going to take the date column, and then I'm going to say I want to split that into three new variables. So here are the new variable names, month, day, and year. You see them here. And the separator that I want to split them on, I need to specify. So I'm going to split them based off of this slash in this case. So it's going to take the first value to month, the second value to day, and the third value to year. And then this argument, convert equal true, says, if possible, convert it to like a new number if you can. So convert it to a numeric variable. And that's because we're coming from a character variable in this particular case. And so we're going to split up this character variable. By default, if we didn't have convert equal true, this would be a character variable with 1, 2, 3 up to 12. This would be a character variable, and this would be a character variable. So convert equal true says go ahead and try to convert that into a numeric variable. And then remove equal true is the default, but if you put remove equal false, it keeps the original variable. So this is going to specify to keep original variable. And so that can be handy because you might want to still access that one later on. And then the opposite of this type of action is then unite. So I might want to take the three variables that I just created and perhaps put them back together. So unite them in some way. So I'm going to take that same function call that I had before. So this right here is ending what we just looked at. I'm going to take the result of that, which has these three new variables. And then what I'm going to do is unite or create a new variable that's a combination of others, a variable called month day. So So here's month, day. And that month, day variable is going to take in the month variable and the day variable, which no longer exist here. So I took the month and the day variable, and I'm going to put them together by separating them with a dash. And so I get 1, 1, 1, 2, 1, 3, etc. And notice I did not put remove equal false here. And so remove equal true is the default. And so it gets rid of those variables that you originally had. So we've lost the month and day variables. All right, let's jump into R and reshape some data. All right, we're in our studio. Let's go ahead and reshape some data. The MyWine data isn't really a data set that we can easily reshape, so we're going to need to read in some new data. So we'll read in some data to reshape. And this is going to be stock data. It's a pretty big file. It's about 2 gigabytes, so I'm not going to download it from the web. I'm just going to read it in locally, but I'll still post it on the web for us. So stock data, read_CSV. It is a CSV file. I have it located here, historical _ stock prices.csv. So again, this is a pretty big data set. It might take just a couple seconds to read in. We can see that there are lots and lots of rows. Right? So there's 220.9 million rows here in 8 columns. All right, so what we want to do here, that's a lot of rows. I don't want to deal with all those. I'm going to go ahead and filter this data set down to only have certain stocks. So you notice that there is a ticker variable in here specifying which stock we're looking at. So we'll just look at some of the most famous stocks. I have a variable that I already created because I don't know these off the top of my head. So I have this variable called stocks that just represents sort of 5 really important stocks according to some websites. So Home Depot, Apple, and a few others. Let's go ahead and filter the data set to only include those particular stocks. So we'll go ahead and take stock data and then filter it. Oh, let's drop that down a line for good programming practices. We're going to filter it where the ticker variable is in this stocks vector that I have created here. And let's just make sure that that works. So I'm not going to save the output of this, even though it's going to take a second to run, just to make sure that this is going to be subsetting the rows that I'm dealing with. And so we do only have 39,000 rows at this point, so that's good. Another variable within this data set is the date variable. And you might actually note that underneath the date, it's actually read in as what's called a date variable. So this is a specific type of variable in R. And the variable that we were working with that Chicago data, we should have converted to a date and handled it appropriately that way, but we didn't. This one is already read in as a date variable. And there's a great package called lubridate that will allow us to parse these dates very easily. So we'll go lubridate. We'll go ahead and read that in with library. And then this lubridate function has functions like day, year, and month that allow you to just pull out those particular values. So what I'm going to do is say I want to filter the rows to only have where we get the stocks that we want and the day of the date variable. Let's say that that is in the vector 2 to 8. So only the 2nd through the 8th. And let me go ahead and wrap this in parentheses just so it's easier to see. I'll drop this down too. And let's also say that I only want to have the year for the date variable be equal to 2015. And let's make the month of the date variable only be equal to 1. So those are going to be the conditions that I filter on. So I only get data for January 2nd through the 8th of 2015. Let's run that and make sure that we get a very, very small data set at this point. Again, pretty big data set, so this is taking a little bit of time to run. So we have 25 rows now. So that probably subsetted that correctly. Remember that the stock market's not open all the days, so 2 through 8 is not necessarily the stock market's not necessarily open all of those days. So the 3rd and 4th, they're off here. Okay, so let's now just look at a couple of the columns that I want to look at. So ticker and maybe the close and the date itself. So we can easily just grab those columns using the select function. So we'll say now select the ticker variable, the close variable, and the date variable. And I'm going to go ahead and save that so I can do something with it next. So we're going to call this my stock data, because I'm very creative. And we'll run that. Again, it'll take a minute, but now we'll have a nice small data set that we can reshape. And so we might think about, well, how could we reshape this particular data set? As it runs here, I'll prepare to take a quick glance at it. So it's done running. It didn't print out, but that's because I don't have my stock data up there. I'll just type this into the console. And you can see that we have basically 5 observations on each one of our stocks. Well, what I could do is look at this in wide format, where the date goes across the top, and then the close value is the actual value within my data set. So I want to take this from long format into wide format. So what I could do is just keep chaining on here if I wanted to, or I can just start over. So I'll just start over for the sake of simplicity. My stock data, and then we're going to pivot wider. And again, I should drop this down. Good programming practices say we should drop down there. So pivot wider, I hit tab just to remind myself of what the arguments to this function are. So names from, where am I going to get the names for the new variables? Well, that's going to come from the date variable. And then values from, I want to bring those from the close variable. And now I run this, and I get a wide data set. So now I have my dates going across the top, and I have 5 observations for each one of my stocks as I go. So this is an example of taking wide data, long data, and turning it wider. Let's go ahead and also knit this document just to make sure that it all runs together. Again, when you knit your documents, it's going to execute the code from top down. So I'm going to hit Control-Shift-K to knit my document according to the YAML header, which in this case is just going to create an HTML document. It's going to render, it's going to run all that code. Again, reading in and manipulating of that data is going to take a minute. Oh, it actually did not find stocks. So stocks was something I made in my environment here, but I never made it within my actual R Markdown document. So what I need to do is take this stocks and actually create it within my Markdown document. It does not have access to it once it goes to knit. It only has access to whatever you've created or read in within your code chunks. So I'm going to come down here and I'm going to add that in. We'll say, where are we? Stock data. So first we're going to create an object called stocks, and it's going to be a character vector with these 5 stocks in it. And now I'm going to go ahead and reknit that, and it should work correctly. But that's an important thing to remember about knitting, is that just because you have stuff in your global environment doesn't mean that whenever you go to knit your file, you're going to have access to those things. You're only going to have access to whatever packages and things you've read in or created within your R code chunks in that particular document. And success, we have a document. So if we check this out, we now have our dplyr examples document where we read in some data. And of course, these descriptions are not as great as you'd like, but we go through, we can see all of the different things that we've made, and we have this now as a reference for later. Fantastic. Let's recap. So we have these pivot wider and pivot longer functions to help us change the setup of our data set. We also have unite and separate as inverse actions on a particular column or columns. Again, the dplyr and tidyr cheat sheets that are linked here are very, very helpful and handy when you're trying to get to used to using these types of functions. So let's look at a big recap as we are finishing up here with this data manipulation topic. The dplyr and tidyr packages from the tidyverse are fantastic for doing most of your common data manipulation tasks. And here are some of the most important functions that we've looked at. Remember that with row manipulations, the main function is filter. For column manipulations, we have select and mutate that are super useful.